Hello and welcome to another episode of It's Not That Simple from the Francisco Manuel dos Santos Foundation. As always, we are back to speak with some of the world's leading experts on a variety of subjects across society, politics, and economics. Today, we're going to be focusing on communicating science. Why is it not that simple? We'll be exploring the role of science in our society and what are the big topics we should be aware of right now. We're going to be doing this with our star guest, Brian Cox. Brian is an English physicist and professor of particle physics at the University of Manchester, a fellow at the Royal Society, and most people will also know that he's quite a popular television, radio presenter and author. He's received a multitude of awards for the work he's done in publicizing science. Brian, I could go on with your CV, but in the interest of our viewers and listeners' times, let's get straight into it. It's amazing to have you on the show. Really looking forward to our chat. Let's start with a general view and your opinion on what the role of science is in today's society, especially in our digital age, social media age, where there's so much noise out there. What's the role of science?
Well, I would say, let's first define science. So I would say it is the way we have, as a civilization, of acquiring reliable knowledge about nature. So that's one definition. One of my great heroes, actually, Richard Feynman, the Nobel Prize-winning physicist, described it as a satisfactory philosophy of ignorance.
Okay.
And those two definitions, actually, I think are very important. So what do I mean by reliable knowledge? I mean that we could ask questions such as, why is the sky blue? Why are leaves green? Or what happens if you pump greenhouse gases into the atmosphere? Those are all questions. Now, what science, I would argue, does is gives us the best answer given the state of our knowledge and the data that we have at any particular time. Very important, going back to what Richard Feynman said, not to assume that it's absolutely right. Scientific knowledge is not something that's passed down on stone tablets from a mountain and can never be changed. It evolves all the time. But I would argue that it's the best we can do at any particular time, constantly changing. So that's the satisfactory philosophy of ignorance. So you put those two things together, and I would argue that science forms the foundation, or at least one of the necessary foundations of our civilization.
You mentioned knowledge and ignorance, and I wanted to pick up on that because, and this is a question, but I'll phrase it in a way which is a little bit my opinion, where historically, knowledgeable people have had a platform. People with ignorance on science have not had a platform. That's not the case today, all right? Everybody has a platform with social media. How much harder is it for you and the world's leading scientists to communicate what's fact and what's science in light of these challenges?
Well, I mean, one thing to say is that I would argue that there are many people throughout history who've had platforms and have known nothing about science. But anyway, given that, I think you're right. There's a lot of noise, and sometimes the noise. I used to think it was kind of amusing. So if you're arguing with someone who thinks the Earth is flat or whatever it is, then it's kind of funny. However, there is, of course, a correlation between believing ridiculous things, which are in many ways harmless, and believing and loudly proclaiming things which affect everybody else. And so you're right. It's one of the great challenges, I think, not only on social media, but actually for our democracies, is how to make the argument, how to allow people to understand that there is such a thing as what I called reliable knowledge earlier, that you could call it, well, let's just call it reliable knowledge. And then there's opinion. And it's not to say that this is the fine line we have to walk when we're communicating science. Nobody, least of all scientists, are arguing that scientists should be the arbiters of policy, public policy, or scientists should not be making decisions on how a country goes about its business, right? This is not what scientists do. We're not experts in it, and we'd make a mess of it. But what's very important is that I think it comes down to how people weigh different sources of information when they're making their own decisions in a democracy, and when they're making decisions about how a democracy should proceed. And that's the key thing. It's so easy for scientists to sound arrogant, and that turns people off. Scientists are not, as Feynman said, right, and we can get into this some more, the key to science is not to be arrogant, not to think that you're right, not to think that you know everything about nature. If you thought that, then there'd be no point in doing research, which is the lifeblood of science. So it's how to communicate that fine line, that there is a snapshot of our understanding, a best snapshot at any particular time. It can change tomorrow or the day after or the day after. But it's getting that, allowing people to have the confidence and the understanding to weigh the scientific evidence and the scientific understanding, and then make decisions about how they should proceed.
When you talk about science in contemporary life, obviously there are big topics which get most of the media attention, and the health of our planet is certainly one of those. I know you have a breadth of knowledge across a variety of areas of science, and we'll get into some of the other ones later. But when it comes to planet Earth, how much are scientists being listened to right now, and how would you characterize the priority to take care of our home environment?
Well, it's interesting. If you look back through the history of climate science, we've known for a long time, decades, that if we continue to put greenhouse gases into the atmosphere at the rate at which we're doing, then the climate will change. Average temperatures globally will rise. We've known that for a very long time. It's difficult, climate science. So if you ask for very precise predictions, then we don't have the ability to do that. But we have a broad understanding of the sweep, the change in climate over years and decades. And the predictions have been broadly correct for many years. I think now the public attitude or understanding of that challenge is changing, because worryingly, we're starting to see it, really viscerally seeing the effects of climate change. So I sense there's a change in public attitude. It's difficult, you see. It's difficult to say we have modeled something which has profound consequences, may have extremely profound consequences. We've modeled it in some computers, and this is what we think, and therefore we should all change our behavior. That's extremely difficult as a political message to get across. And broadly speaking, our civilization failed to do that over the last decades. The problem, of course, the tragedy of it, in a sense, is that the models were broadly correct. But the longer you leave it, the more expensive and difficult it is to correct, and the more tragic the consequences. And that's what we're seeing now. So I'd argue now, I feel, just so looking across various societies, different countries across the world, that the message is now pretty well understood. But unfortunately, that's because the people are seeing it with their own eyes and feeling the consequences. So that's climate. You asked also about why it matters, and of course, we could have long discussions about why it matters in terms of food supply and so on, global health, migration across the planet. But I think more broadly, I was asked to deliver a message at the COP Climate Summit in Glasgow. It was a great honor, actually, to make a small message to world leaders as part of that summit. And I said, it's possible, given what we know, that the number of civilizations in a typical galaxy is small, low. It's interesting, actually, the biologists that I ask tend to be rather more pessimistic than the astronomers, because there are, 400 billion suns, give or take, in our galaxy. Most of them have planetary systems. It's 1 trillion planets or more in the galaxy. There have been 13 billion years of cosmic history. So you might say, well, surely biology has constructed things like us, or perhaps far in advance of us, out there amongst the stars. Well, maybe so. We don't have any evidence, though. But actually, when you look at the history of life on Earth, one fact, I'll give you one fact, there are many more, but one fact is that here on this planet, it took around 4 billion years, 1/3 of the age of the universe, to go from cell to civilization. That's a very, very long time for an unbroken chain of life to exist on a planet. That alone should tell you that perhaps there may not be anything unusual about microbes scattered around the galaxy, but perhaps given that 4 billion year timescale, there may be something unusual about intelligence and civilizations. So let's make the argument. Let's imagine that civilizations are very rare. You can make the argument that maybe there's less than one on the average per galaxy at any given time. That would mean that we are remarkably valuable, notwithstanding our undoubted physical insignificance. And I think that perspective, Carl Sagan, one of my great heroes, always said that astronomy is a humbling and character-building experience. So the humbling is easy. You know, we sit on one planet around one star amongst 400 billion in one galaxy, amongst 2 trillion in the observable universe. Humble, right? The perspective. But character building, I think that it's possible that places like this, where there are collections of atoms like you and me that can think and that can understand and explore the universe, might be so rare that they are unimaginably precious. And therefore, what we do on this planet, what we do to our civilization, what we do to the planet actually does matter beyond the shores of our planet, potentially. And so I think that's a very powerful argument for just allowing the perspective that astronomy gives us to inform the way that we behave and the care that we take of each other, of our civilization, but also of the natural world on which we depend.
There's so much to deconstruct there, but I did want to get into the subject of space travel. You mentioned planets, you mentioned our galaxy. Obviously, some of the more extreme thinkers might believe that even if we do destroy this planet, eventually, it's okay because we'll have others to colonize. Space travel is becoming more common now, even for I would say, rich amateurs around the world. How do you react when there are those who argue that we can colonize other planets and there is a plan B to look into if this one goes wrong?
It's a matter of timescale to an extent. I mean, let's just set the scene. I mean, it is true that this planet will become uninhabitable in of order 1 billion years or something, right? So there is a time limit. So we've got to get out there to the stars eventually. But let's talk in timescales of centuries. Let's talk in the timescale of 100 years. I do not think that we have the capability to terraform, for example, Mars on a 100-year timescale. Let's think about what we're talking about here. Mars is the only other planet that we could hope to visit. We're not going to Mercury. It's too hot and too cold, depending on where you are on the planet. Venus is definitely too hot and everything else is made of gas, right? So we're not going anywhere else other than Mars. Mars is a horrendous place, right? It is not a place that we would want to live. Clearly, obvious things like its atmosphere, tenuous as it is, I think we will be there in my lifetime. I think in the next few decades, there will be a crewed mission to Mars.
Okay, so physically on the planet, you think it's possible?
I think so, within the next few decades. Yeah, I have no argument with SpaceX, for example, or indeed NASA when they have a long-term plan that involves going to the moon and then onwards to Mars. We could do it. We could do it with sufficient investment, I think, in the next decade.
Wow.
Whether 10-year timescale, whether we will or not is another question. It's about investment. However, there's a big difference between sending an Apollo-like mission, even though it will be more, it'll be more of a permanent base if we set a base up on Mars, and we'll be talking about 3, 4, 5, 10, 20 astronauts maybe at some point over the coming decades, and it'll be a wonderful achievement. It'll be a stepping stone. But the idea that you can build a civilization on Mars that can be self-supporting, that could sustain itself even if the Earth was completely destroyed, is, to me, science fiction. I think we're centuries away from that kind of capability. So for me, the simple fact is that, as you said, there is no plan B. There will not be a plan B for at least 100 years. And I would think more than that, because we're talking about tremendously difficult things to do. And so I think we need to focus on making sure that this planet supports the civilization that depends on the planet.
I did want to get your take on the role of artificial intelligence and how it could help speed up the process of, in this case, speaking specifically about space travel and technology overall. I mean, I think it's very much the hot topic of 2023, at least in my community, AI, right? It suddenly has become an expression that people use, I would say, in day-to-day conversation because of the rise of ChatGPT, because of more tools that are being used by everyday professionals around the world. How has AI changed your role as a scientist, and what impact does it have on how quickly technology is moving?
Well, the thing to say about AI is there are multiple issues here. We all use it every day. An AI system is essentially a predictive system. So AI systems predict and they learn. And that's how ChatGPT works, the translation software. Self-driving cars, for example, safety assistance systems in cars, all those things are AI systems. So we all use them every day, and they make our lives better because they make us more productive. And that's one sort of road in AI. But I think then there are problems. Maybe they're not broad enough for us to talk about. There are problems with regulation, for example, in particularly regulating self-driving cars, for example. What happens when an AI is driving a car and the car crashes and so on. But those are regulatory issues. But I think probably what you're referring to, there are two threads that people find more interesting, I think, in the medium term. One is the question, but when you say AI, I think a lot of people think of Terminator or something like that, right? So think of some system becoming sentient and then wiping us out. And I think most experts I speak to think we're a very, very, very long way away from what you might call artificial general intelligence, which is, something that can really, really outthink us absolutely. However, you could imagine, I had a conversation actually with an expert a few weeks ago on this. You could imagine, for example, that how much responsibility do we give AI systems? So, for example, imagine that we handed a nuclear deterrent over to an AI system. What sort of a threat would that be? So it's not that the AI is going to sit there and think, I can wipe these people out, that'll be fun, and do it intentionally. But increasingly, we are allowing AI systems to make decisions. Now, some of those decisions, most of them at the moment, probably all of them, are kind of trivial decisions. But a decision on how to drive a car is less trivial and potentially problematic. But if it's a decision about how to launch nuclear weapons, because you can see it might give you an advantage, or appear to, as a country, because it'd be very fast and it can work things out. But I think most of us would prefer a human in the chain to exercise some judgment, moral judgment, about really serious decisions. So I think, again, it comes down to regulation at the moment. I don't think there's a technological threat in the sense of sentient robots coming to wipe us out or something like that. But I do think there are serious issues about how we choose to give AI systems decision-making power. And I think those frameworks are beginning to be developed now.
We've touched a little bit upon the universe, galaxies. I know you've done a lot of work and research around black holes, and I did want to bring that topic up because it's very complex, I think, first of all. Everybody thinks they know about black holes for the science fiction movies we may have watched. But what is, and I know it's also not a topic that you can cover very quickly, but what is the one fact about black holes that we should know about or that we should care about that has taught us the most about the universe?
Well, so black holes, I mean, they're the two kinds of black holes, really. There's the ones that form when massive stars collapse. And there are black holes at the centers of galaxies, supermassive black holes. These are big things. There's a galaxy called M87. We have a very famous image, the first image gathered by a telescope called Event Horizon of a black hole in M87, which is 6 billion times the mass of our sun. So these things are big, powerful things. They exist. The interesting thing about them, though, beyond the fact that they're astrophysical objects that are very strange and powerful, the interesting thing is that in trying to understand them over the last 50 years or so, going back to Stephen Hawking's work in the 70s and back further, actually, in trying to understand them, we've been presented with very well-defined, sharp questions about fundamental physics. So they challenge us. They challenge us to think about what we know about Einstein's theory of general relativity, which is our best theory of gravity in space and time, and quantum theory. Quantum theory is our theory of everything else. And they challenge us to think very deeply about the fundamental basis of those theories. And that's really, I think, why they're so interesting to theoretical physicists. And the short answer to your question, give you one fact about them. In trying to understand whether these things destroy information in the universe at a fundamental level, do they erase information from the universe? We've been forced to confront a question about the nature of space and time themselves. So we're asking questions because we're forced to, by studying black holes, about, well, for example, are there building blocks of space and time? And the very short answer to a very long story that goes back a long time is that we now have theories, really physical theories that we can think about, which tell us that space and time emerge from something deeper. And what do I mean by that? We talked about AI earlier, right? So what is consciousness? One of the big questions, right? What does it mean to be conscious? What you could say is, well, whatever it is, a property of nature that you and I and everyone listening and watching thinks it's a property of nature, but it emerges from something deeper, which is a pattern of atoms. It's a remarkable thing. We have no idea how it emerges, but it does. Little idea, in deference to my colleagues that study it, right? So, but it's a difficult question. In the same way, we're beginning to suspect that space and time emerges from something that doesn't have time in it. In the same way that thought, consciousness, emerges from things that don't have thought in them, which is atoms. That's a remarkable thing.
Wow. Yeah, and I would say that would be a topic in itself for a different half-hour show.
There's a lot there. The nature of free will and consciousness, the nature of time.
Yeah, for sure.
Moving on.
For sure. Before we get to the quick fire round that we always have at the end of our shows, I did want to ask you, what is the most amazing, mind-blowing fact about the universe that regular people like myself should know about and care about? Within all the facts and magical functions of our planet, our galaxy, the universe, what is one thing that you're still incredibly impressed about that we should know?
I'm astonished, and everybody knows this actually. I'm astonished the universe can explore and attempt to understand itself. If you think about it, we know that 13.8 billion years ago, the universe was very hot and very dense, only really had, shortly after the Big Bang, had hydrogen and helium in it. And then over 13.8 billion years, and a bit of lithium for the experts, right? And over 13.8 billion years, then it's structures have emerged in the universe like us, right? The Earth with its ecosystem, and collections of atoms that can think, which is what a human being is. I find that astonishing. And I think many people now think that one approach to cosmology is to start with that remarkable fact. What is the most remarkable thing about the universe? It's that a civilization exists in it, at least one, right? And then work back from that and say, well, is that fortunate? Is it tremendous good fortune? Is, you know, the hope in cosmology many years ago was perhaps this is the only way it could be. And there's still that hope, you know, perhaps we can find some kind of theory of everything from which it flows inevitably, that you'll get collections of atoms trying to understand the universe. Carl Sagan, again, he had a wonderful turn of phrase. He said once that a physicist is a hydrogen atom's way of understanding hydrogen atoms, right? It's a remarkable thing. So that's what I would say. Just think about, not, as you said, that it's remarkable. There are billions of galaxies, there have been billions of years, trillions of stars and suns and planets. That's all mind-blowing. But the most remarkable thing is that you exist at all. That, to me, given the action of simple laws of nature, is astonishing and worthy of thought.
All right, Brian, we're going to get into the quick fire. So just one word or one sentence answers here, please. And I know
Okay.
that you could obviously spend more time answering these, but
Yeah.
what is one personality trait a good leader could really benefit from having, from your experience? And
Humility. Humility, as I said before. Can I have one more than one sentence for this?
Yes.
Just to say that I strongly recommend that there's an essay by Richard Feynman called The Value of Science. You can get it online, freely available, 1955, I think it was. And he talks about what the study of nature can teach us. And what we said earlier, this philosophy of ignorance, this humility in the face of nature, the desire to acquire new knowledge, which means you accept that you don't know everything. And it's that, and Feynman said it, that's the open channel, that's what he called it, the open channel to wisdom, to enlightenment even, is to accept that you don't know everything and allow new ideas to form, allow your mind to be changed by the experiences that you have. That is so important. And it was, you know, it's, read Feynman's essay. I would strongly recommend it.
Gotcha. That was the last time I'm permitting more than one sentence.
Sorry, but I had to say that.
What is the biggest challenge humanity faces today, in your view?
It's a political challenge to understand how to run a planet, how to run a global civilization.
Okay, that's a big one. Again, could be deconstructed. If you could change one thing in the world today, what would that be? If you had the power to change one thing.
I would ensure that everybody has the luxury of education.
Yeah, and what is the most important learning of your life and career?
I think from being a research scientist, it's, because Feynman as well said this, it's the experience with being wrong most of the time when confronted by nature.
Really good. I'm going to make another one up on the spot because we still have just one more minute, and you know what? I can. No one's going to stop me. Maybe you will, but do you believe in alien life, and why or why not? And this is just kind of a hot topic with the declassified NASA files and a lot more noise around this recently.
If I had to guess, I would say that there would be microbes in the solar system. I think that they may have existed, may still exist subsurface on Mars, and may exist, for example, on Jupiter's moon Europa. However, complex life, multicellular life, I think will be very rare. It's a guess, it's my opinion, But I think you will have to go many thousands, if not millions of light years in every direction to find an ecosystem as complex as the one we find on Earth.
Wow, that means we are indeed special. Brian, it's been an absolute pleasure, privilege to be able to sit here and discuss so many important topics around science and the fact that you have so much knowledge around the work you do as an astrophysicist as well, so many pertinent subjects to get into around this conversation and try to simplify it for us. So thank you very much. All the best with your life and work.
Thank you very much. It's been a pleasure.
It was indeed amazing to speak with Brian Cox on another episode of It's Not That Simple from the Francisco Manuel dos Santos Foundation. See you soon.